In this video, we are looking at motion in 2 dimensions. In the first question, we've got forces F1, which is 3i plus 2j newtons. F2 is minus 5i plus 4j newtons. And F3 is 5i plus 6j newtons. And they're all acting on a particle of mass 3 kilograms. We need to find the acceleration of the particle. So we're going to be using F equals ma. And F is the resultant force. So it's going to be F1 plus F2 plus F3. So it's 3, 2 plus negative 5, 4 plus 5, 6. So the resultant force, add up the i's, 3 minus 5 plus 5 is 3, and 2 plus 4 plus 6 is 12. So it's 3 i's and 12 j's. So that's the resultant force, 3 i's plus 12 j's, and that's equal to mass times acceleration. So 3i plus 12j equals 3a. To get a by itself, divide both sides by 3. So we get 1i plus 4j, and its acceleration, it's in meters per second squared, or meters per second per second. It's in terms of I and j, and that's absolutely fine. Acceleration is a vector. It's got magnitude and direction. One for you to try. See if you can give it a go. So again, we want F equals ma to find the acceleration. F is the resultant force. So we're going to add up all of these forces. So it's 2, 3 plus negative 3, 1 plus 5, negative 2. So add the i's, that's 4, and add the j's, that's 2. So the resultant force is 4i plus 2j. So 4i plus 2j equals mass, which is 0.5, times acceleration. To get acceleration by itself, double both sides. So it's 8i plus 4j, and again, meters per second squared. Another question, a resultant force of 3i minus 2j newtons acts on a particle of mass 2 kilograms. Find the magnitude and bearing of the acceleration of the particle. So let's find acceleration again. So F equals ma. So 3i minus 2j is the resultant force, and that's equal to 2a. So the acceleration is 1.5, or 3 over 2i, minus 1j. We want the magnitude and bearing this time. So it's going 1.5 to the right and 1 down. So the magnitude is the hypotenuse, and the bearing is the angle from north. So let's do Pythagoras to find the magnitude. The square root of 1.5 squared plus 1 squared is root 13 over 2, or 1.8. Put root 13 over 2. So root 13 over 2 meters per second per second. And the bearing, so if we work out the angle x here, so it's opposite and adjacent, and then we'll add 90 onto it. So tan x is TOA, O over A, 1 over 1.5. So x is shift tan, 1 over 1.5. and we get 33.7. That's the angle X, 33.7. But we want to add 90 onto it. So 90 more, and I'll give it to three significant figures, 124 degrees. One for you to try, see if you can give it a go. So again, we've got F equals ma. The resultant force, 6I plus 9j, equals the mass, which is 3 times the acceleration. Divide both sides by 3, so we get 2I plus 3j meters per second squared. We want the magnitude and the bearing. So it's going 2 to the right and 3 up this time. So the magnitude is Pythagoras, and the angle, let's use alternate angles. So we want this angle here, which is going to be equal to this angle here. So the magnitude, the square root of 2 squared plus 3 squared, is root 13. So square root 13 meters per second squared. As a decimal, 3.6 or 3.61. And then we've got the opposite and the adjacent. So tan x is 2/3. That's actually the same as the last question. So shift tan 2/3 will give the same answer, 33.7. 33.7 degrees. And again, because of alternate angles, this angle is the bearing. So I'll put 0, 3, 4 degrees.